Hi everyone, welcome back. In this video, we will explore the four core principles of object-oriented programming in Java, which is encapsulation, abstraction, polymorphism, and inheritance. This is part 3 of our class objects and open Java episode. In the previous videos, we covered how to create classes, objects, and basics like blocks, methods, and constructors. If you haven't watched those, check them out. But you can also start here without missing the essentials. So let's dive in and begin with encapsulation. Encapsulation restricts direct access to parts of object to protect data and control modification, meaning they will try to hide some parts of the object to keep the data safe and control how it is changed. Think of it like your smartphone. You can use the screen to interact with apps, but you can't directly access the internal components like the battery and memory unless you open up the phone and then you take out the battery and the memory inside it. So encapsulation in Java works similarly. Data within a class like private variable is hidden and public methods act as a screen, allowing us to safely access and control over those hidden parts, which is our private variables, which are hidden, and our public methods will let us to act on those private variables. In Java, we use private variables to restrict the access and public method to control it, keeping data secure from unwanted changes. Abstraction. Abstraction is a way to simplify complex systems by showing only the important details and hiding everything else. Imagine using your Google search. All you see is a search bar and a button. Behind the simple interface, a lot of things are happening. Google is retrieving data, processing it, and delivering results. But you only see the final results. Similarly, in Java, abstraction helps us simplify by hiding complex detail and only showing what users need to see. In Java programming, we use abstract methods and interfaces to create these simplified views so users don't need to worry about the complex code behind them. Inheritance. Inheritance let us create new class based on an existing class, allowing it to reuse code instead of starting from the scratch. So for example, let us take social media login that we will see whenever we go to the websites like Canva or Spotify. So let's assume that there is a class called social login class, and from that class we can create a specific classes for Google, Facebook, and other social media logins. So we'll have login supported to our application via Google class, then Facebook class, and social media login class. So each can inherit the common feature like requiring username and password and then add its unique details, thereby letting you to log in with Google, Facebook, or other platforms because they are all similar login structure. So this feature is coming from inheritance. Finally, what we have is polymorphism. Polymorphism means many forms and it lets one method work differently depending on the object it is working with. Let's go back to the social login. Each login method, for example, Facebook, Twitter, Google, collects data differently, and Facebook may gather friends list and posts while YouTube focuses on video preferences. Although each platform uses unique approach, the basic login functionality still remains the same. So in Java, polymorphism let us use one interface to perform different actions based on the specific object, allowing for more flexible code. So that's the basic understanding of what polymorphism is. And your polymorphism works two ways in Java, which is compiler time polymorphism and there is runtime polymorphism. Compiler time polymorphism is also called as static polymorphism, occurs when multiple methods in a class have same name but different parameters. Consider that you have a class called calculator and it is going to have a method called addition. Now, when the method name is called addition and it is also going to have a type called integer. So this method will take two parameters inside, which is can be integer a and b, and it has to return the sum of a and b. Similarly, I can have one more method called add, but this can have type double. So when this is going to be of type double, it will also take input parameters as double and it will also return me sum of the two input parameters also in double. But when you observe it, both the methods have the name add, but their return type and arguments are different. So during the compiler time, Java can recognize this difference and will call the appropriate method names respectively. So for integer numbers are going to be passed, then the integer addition will be called. When the double numbers are going to be passed, then the double number will be called. So this they will call it as static polymorphism or compiler polymorphism. Secondly, we have another polymorphism called runtime polymorphism. So they are also called as dynamic polymorphism. And another word for this is method overriding, meaning so you have a parent class and then you have a subclass. The subclass will provide its own implementation of the method that exists in the parent class. Example, assume that you have a class called animal and it has a method called sound. Now you're creating a subclass called dog, which is going to extend from the parent class animal. So automatically the method that is present in your parent class is going to come to the dog class, which is the method called sound. But inside your sound method, which is present in your subclass, you can hand your implementation differently from the parent class, even though the method name is same as that of the one that is present in the parent class, which is the method called sound. So you have the sound method in the animal class. Now you have the sound method in the dog class. Finally, when you're trying to create objects referring to the animal parent class, and when you create an object for dog class, and when you try to call the reference pointing towards the sound method, that compiler will still be able to recognize the sound method from the subclass, which is the dog class. So here this is not happening at the compiler time, it is happening at the runtime. So this is called a runtime polymorphism. So the JVM which determines which method to invoke at the runtime, allowing for dynamic method resolution. So these are the two types of polymorphism that can happen in Java. So with that note, let's focus on demonstration of all these features using a class